If I were doing this question, I would look up and down for anywhere I could simplify early. I can simplify 4ab and negative 8ab. I could simplify there. I can simplify b's. Oh, that should have changed color, you son of a... I can simplify b's and b's there. Before I did anything else, I would simplify that. Now, what can work with 4 and 8? 4. So the 4 would disappear, and this 8 would become a 2. Right? Okay. Negative 2 and negative 8. If there's two negative 2, a to the negative 2 up top, then I can get rid of 2 of them on the bottom, yes? So this will become a to the negative 6. Any b's up there? No, so those b's have to stay the same. What about this side? I got negative 3 down there and negative 4 up there. So can I get rid of all of them? And this will become b to the negative 1. Everybody with me? Now I'm in a better shape. 32a squared b to the negative 1 times 2, negative 2, is negative 64a squared b to the negative 1. Over. I got rid of that 4. Negative 3, a to the negative 6, b to the negative 2. Do 64 and 3 simplify? No, but 2 negatives make a... So those are gone, not the 6. 2 minus 6. Negative 1 minus 2. B. Now that was a lot of stuff going on. So you check 11A, there it is. Now, that doesn't look like the way I wrote it, does it? Except that you remember that what officially is this over? 1. So it is 64A3B over 3. That's the exact same thing. Everybody cool? Remember, once you decide on what you are going to simplify, you must finish that particular one before you go on to simplifying somewhere else, all the way to the end. Don't start, I'm going to get rid of A's here, but B's over here and numbers here. Don't do that. Go through everything at once. Now, of course, could you also, if you wanted to, just have gone 32 times negative 8, which is negative 256. A2 minus 2 is 0. B to the negative 4 over negative 12. A to the negative 8. B to the positive 6. Could you have done, B to the positive 5. Could you have done that and then simplified? Yes. You would have gotten the same exact answer. Who needs to make that decision? You do. All of this is the same math you've always done. If I gave you 32 fourths times 8 thirds, you would do that part of it however you would normally do that part. When I do that question, I cancel to get 64 over 3. That's how I personally do the question. Now, I can't show you every combination that you could possibly do to do a question like that, right? I can only show you ways to do it. And D was the other one, correct? So, the way it's written, divided by, right? So what that actually is 5a cubed b squared times negative 2a to the negative 2b all to the negative 3 over negative 5 a to the 8, b to the negative 9, c to the negative 2. Now you have a couple of options here, but it gets tricky depending on what you're going to do. What do you see there that you don't like? What is written right there that's not allowed? There's some negative exponents. Does that negative exponent, is it attached to the yellow, the pink, or to both? Only to the yellow. So, if we were going to move, if we were going to move anything, we would only move this yellow down here. What would change? Would that negative 2 change? No. Would that negative 2 change? No. Would that negative 3 change? Yes, because that's what we moved. Now, what about here? Could we move all this up? We could. Would that negative 9 change? Negative 9. Why did that? Oh yeah, negative 9. Would that negative 9 change? No. Would that negative 5 change? Would that negative 2 change? Yes. So I could rewrite it that way, moving everything now. That's one option. Could I also distribute these exponents in here to get rid of these brackets? Would that be allowed? Of course it would. Who makes the decision? You do. So who asked about 11D? I can't remember. Both of you? Okay. So what do you want to do, Rihanna? Because let's follow your path here. What would you do now? You would distribute in the exponents. Okay. So nothing's happened to the first one, right? So it is still going to be 5a3b squared times negative 2 to the negative 3, right? Negative 2 to the negative 3. A to the what? Positive 6. And b to the what? Negative 3. Agreed? Over negative 5 to the negative 2. A to the what? Negative 16. And b to the 18th. Everybody still okay? Yes. You cannot just put negative 8 because it isn't negative 8. Negative 2 to the 3 is negative 8. Negative 2 to the negative 3 is negative 1/8. Okay, so you got to be careful about that. Are we all okay to hear? We just distributed, yeah? Now, what would you do now, Rihanna? You would clean up the top. Now, what is going to mess you up at the top is this situation here, right? So what I like to do, if I don't know what I'm doing, I'm just going to leave them. 5 times negative 2 to the negative 3. Then I'm going to do my A's and B's. What is A? A to the 9th. And B to the negative 1. Because 2 and minus 3 is negative 1. Right? Everybody's good? Over. Down here, I got negative 5 to the negative 2. A to the negative 16, B to the 18th, correct? Now, what scares you? This is a mess, right? But that's easy. That's easy. Let's tidy them up. What's 9 minus 16? 25. A to the 25. It's positive, we're happy. What's negative 1 minus 18? Negative 19, right? So our B's got to be down here. Now we just look. What's happening here? That's a negative, right? So where does that 5 have to go? Up. And it's going to be negative 5 to the positive 2. So this is going to be negative 5 squared. Where's this going? Down. So that's going to become, that guy's gone, negative 2 cubed. What is negative 2 cubed? Now, Avneet, it's negative 8. And negative 5 squared is 25 times 5 more? 125. And then if that simplifies, which of course it doesn't, we're done. Everybody cool? It's just the laws you already know, but you have to pick one and follow it all the way through. Now, when I say pick one and follow it all the way through, sometimes you pick a bad one. Like when we did what Rihanna wanted to, distribute all this in, that gave us this mess, right? I don't want to deal with that. So I would have moved this whole thing down right away, and I would have moved this whole thing up right away to get rid of all my negative exponents at the beginning. But I would still get the same answer. And you can see you would. This negative 5 would come up here and become squared, which would be 25 times 5. There's our 125, right? It's just a matter of practice. Anything else? From 1 to 17? Excuse me. I am not feeling very well, ladies and gentlemen. My kids had the death plague for the last week, and it has finally gotten to me. Pardon me? These would not change. Nope. Nope. Only the thing that we're moving changes it. Okay? Isabel. 16. Okay. P equals that, Q equals that. R equals that. If P equals that, Q equals that, R equals that, and that equals that, then N is equal to. Oh, right, there's N. Okay, I had to find where N was. Okay, so PQ would be that times that, yes? Right? So that would be 6 times 10 to the negative 7 times 2 times 10 to the 8th, right? Right? And over 3 times 10 to the n. Everybody cool? Everyone agree? Now, what do you notice there, and there? They're all the same thing, right? So I could assign them a variable if I wanted, couldn't I? Isn't this one 6a to the negative 7th times 2a to the 8th over 3a to the n? Isn't it? Because the a's are all 10. Agreed? Now, what would I do with that and that if I'm multiplying there? I'd add them. And what would I do with 6 and 2? Multiply them. So I would have 12a to the 1. Agreed? Over 3a to the n. Agreed? Now, all of that has to equal 4a to the 6th. Yes? Does everyone agree? Okay. Well, 12 divided by 3, there's our 4, right? And I need a to the 6th. What am I going to do with 1 and n? Subtract. So 1 minus n has to equal positive 6. So what does n have to equal? Negative 5. Everybody cool? And this is a handy-dandy trick that if you've been in my previous math classes, you've seen many times. If something is ugly, you don't like the way it looks, but you see a bunch of things are the same, make it an X, or a Y, or a P, or a Q, or whatever you want. Because when we did that, this became super easy, didn't it? Right? Everybody else is good? All right. Please turn to your favorite page and mine, 12. It's not really your favorite page. Why would 12 be any better than 11? It's a stupid thing to say. Speaking of numbers, of course, you all know the joke. Why 6 was afraid of 7. Because 7, 8, 9. But do you know why 7, 8, 9? Jack does. Why? You're supposed to eat 3 squared a day. 3 square? 3 square meals? 3 squared, 9? Yeah, getting an exponent joke in there on a Thursday. It's not a short day anymore, so, only sometimes. Use your calculator, find that. Half of you already know the answer, half of you have forgotten the answer. What is it? 3. Use your calculator, find that. What is it? No. 3. Use your calculator, find that. What is it? No. The third one is? 5. Now, look at this. This says that 3, 9, and an exponent of 1/2 all share some kind of relationship, correct? Is there another relationship between 3, 9, and an exponent that you know of? What is the relationship? The joke I just did, right? 3 squared equals 9, right? What is the inverse of that operation? Why does 3 squared equal 9, Jorik? Because the square root of 9 equals 3. Agreed? Now, if the square root of 9 equals 3, and 9 to the 1/2 equals 3, then what do I know about the square root of 9 and 9 to the 1/2? They have to be the same thing. Right? If A equals B and B equals C, then A must equal C. Right? Now, looking at the way I have written this, think back to grade 10. What should be right there? A 2. What is the exponent that 9 always has that we don't write? 1. Notice, 1, 2. 1, 2. Let's look at the next one. Is there a relationship between 3, 27, and the exponent? Of course there is. 3 cubed is 27, which must mean the cubed root of 27 equals 3, which must therefore mean that 27 to the 1/3 equals the cubed root of 27. What number should be there with 27? 1. Notice, the exponent with the radicand is the numerator, the index is the denominator. Easy peasy lemon squeezy. You've all seen this before. You all saw it in grade 10, at least if you were in my class. If you were not in my class, I cannot guarantee that. Everybody cool? And of course, obviously what's going to happen here, the 4th root of 625 is 5. Because 5 times 5 times 5 times 5 is 625. Everybody good? So all you have to remember is if I have a rational exponent, and remember, rational numbers are written like that, the y becomes the index, and the x becomes the power. No matter what it looks like. That always works. So let's look at this situation. I have a number, yes? I have a base. What is the base? 0.04 to the 3 halves. Where does that denominator go? It becomes the index. Where does the base go? In here. This is called the radicand. And where does the numerator go? Right there. Now, some of you will have problems putting that into your calculator, but of course you don't need to, because this is really what? What is that really, since we're in grade 11, and you all know I hate decimals? What is that really? 4 over 10? 4 over 100. Cubed, yes? Now, if I had this, 4 over 100 squared, where would that 2 go? Where would that 2 go if we were doing yesterday's exponent work? Where would that 2 go? It would go to both, right? And I would get 4 squared over 100 squared, yes? Which would be 16 10,000ths. Agreed? Okay. So you guys are smart people. You've already seen that exponents and square roots are related. So here I have a square root of all of this. Where does this square root sign go? When it was squared, it went to everyone. So where does the square root go? To everyone. This is the square root of 4 over the square root of 100 cubed. What is the square root of 4? 2. What is the square root of 100? 10. All cubed. What is 2 cubed? 8. What is 10 cubed? 1,000. 8 1,000ths is 0.008. Easy peasy lemon squeezy. All without a calculator. Right? Let's look at the next one. This is barfy. Because how can we multiply 27 by itself 4/3 of a time? It can't be done, can it? So we recognize that this situation works here. So the 3 becomes the root, the 27 becomes the radicand, and the whole thing is to the 4th power. What is the cubed root of 27? No. 3 to the 4th power, which is 3 times 3 times 3 times 3. What's 3 times 3? 9. What's 3 times 3? What's 9 times 9? 81. And it's done. Is everybody with me? Is this coming back to everyone? That is what's important, because you have seen this before. Now, just like I said yesterday, are we allowed to forget about all the math we've done before? No, as a matter of fact, this is the first year where you can't forget any of the math you've done before. Because we are bringing stuff back that you haven't seen since the 7th and 8th grade, yes? You have to remember it all. This is only one lesson ago, though, isn't it? What do I do with exponents over a bracket? I multiply it in. What's 2 times 1/3? 2/3, not a trick. So that is 8 to the 2/3. Now I can deal with that. Do so. Where does the 3 go? Where does the 8 go? Where does the 2 go? Told you, I'm not well. You guys do D, because it's exactly the same as A. No calculator allowed. Anyone want the magic pencil? It's wireless. You can show us what you did. I'll bring the computer to you. Okay. I know it's scary when I say no calculators allowed. What's that really? Blue screen? What's that really? 49 over 100 to the 1/2. Where's the 2 go? To the 1st power. What's the square root of 49? What's the square root of 100? Done. Since you guys hate fractions, they scare you, make you want to cry and hide under your bed. That is, of course, 0.7. What's different in E? It's a decimal form. Sure. Where? What do you do over decimals? Or over brackets? I know that it's blue. Two times 1/3 gets me 2/3, right? The denominator becomes the radical, or the index. The base becomes the radicand. The cubed root of 8 is 2. And then that is squared. So down here, what makes this weird? That's a decimal. But you guys all like decimals better. You all want to use decimals all the time. So you should have no problem with this, should you? What is that decimal really in the way we really do math? 15 over 10. And what you do with every single fraction you ever see, Isabel? Simplify it to what? 3 over 2. That is now 16 to the 3/2. And now you can do that in your sleep. Because it's the square root of 16 cubed. What is the square root of 16? 4. What's 4 cubed? 64. And lastly, what is 0.75? 3/4. 4th root of 81 cubed. We already know the 4th root of 81 because we did it in question B. What is the 4th root of 81? 3 cubed is 27. Now all this should already be back in your heads, yes? What have you noticed about all 6 of these questions? What would you say if I asked you to compare all of our answers? What are they? Don't say they're all highlighted in blue. Wise ass. They're all rational, aren't they? And easy to get, yes? Because it all happened to work out perfectly, right? How many numbers are in the universe? Infinite. Is it going to work out perfectly every time? No. So sometimes we're actually going to need to use our calculators when we need an actual value, right? It doesn't do any good in the real world to say, oh, the answer to that is the square root of 9 over 15. Because that means nothing to anybody, right? You would not go to Home Depot and say, I need the square root of 9 over 15 feet worth of pipe, would you? No, you need an actual value. So in math, we like to keep things pretty, but in the real world, things are dirty. See what I did there? What would we do here in math class? What would I write there? What's another way I can write that in math class? We just did it 6 times, ladies and gentlemen. 5, 5th root of 8, to what power? 2. Now you guys are intelligent people. Does 8 have a 5th root? No, the biggest root 8 has is what? A 3rd root, which is 2, correct? Nothing else. So if we can't make it prettier and we need a value, we have to use our calculator. Everybody good? And of course, there's 2 ways to do it. There's the way you see it right here. 8, exponent button, whatever your exponent button is, bracket, 2 divided by 5. Close brackets. That will get you the right answer. If you've written it out this way, it's a real pain, so don't bother. Every calculator makes this very difficult to do. And it's different depending on what calculator you have. So I'm not even going to bother with it. Do it from here. What would this one be? 0.6, exponent button, bracket, 15 divided by 7, close brackets, and equals. Make sure you can get your calculator to do that for you. Because part of this class will be spent getting math done, and part of this class will be spent getting actual values. Everybody understand? We will do some work in this class that is very similar to your physics classes if you've taken physics. In physics, you need a value. You don't say the guy jumped out of the plane and reached a speed of 8 to the 2/5 meters per second. Right? You give an actual value. Everybody cool? And that takes us immediately to our next question, which requires you to find me an actual value. And again, this should be familiar because it's from your grade 10 book. This particular question. One of those you can actually do. Two of them you can't. Which is the one that you can actually do in your head or without a calculator? A, B, or C? A, of course. Why, Jack?
Because 27 to the 2/3 is easy.
Yeah, sure it is, right? Because 27 to the 2/3, 0.01 times 27 to the 2/3 is 0.01 times the cubed root of 27 squared, which is 0.01 times 3 squared, which is 0.01 times 9, which is 0.09. Can you do that with the other two? So if you can't get an actual value by doing math, where do we go? To our calculator. And to do that on our calculator, we have to know bed mass. What are we going to do first? Are you going to deal with the 0.01 or the 200 to the 2/3? 200 to the 2/3. Most calculators can figure out bed mass when you punch it in. Some can't. So make sure that your calculator is one that can figure out bed mass no matter how you punch it in. Because there are some that will not. So this is, of course, B equals 0.01, 200 to the 2/3. And if you punch that in the way you see it, for most of you, you will get the right answer. 2 divided by 3, close brackets, equals. Most of you will get the right answer because most of you have a complex enough calculator to figure it out. But what if you don't really know how to punch it in? Then you know bed mass. What would you punch in first? You would punch in that first, then hit equals, then push times 0.01. Is everybody good? Everybody can use their calculators? Everybody can do it without their calculators? Spectacular. Let's make sure. You guys do C. I'm going to do C right here on my calculator. Oh, my calculator's not turned on.
That's a problem.
It is a problem. And what do you get? What? 0.15. 0.15?
That's not what I got.
.153. Is everybody good? All right, let's make sure. Please notice I have once again been very mean. No calculators. Can you that? What is it? 0.3 squared, which is what? 0.09. Where does that extra 0 come from? Shouldn't it just be 0.9? Why not? What is that really? No. That's 3/10, correct? Which is squared. Where does that 2 go? To everywhere. To get 9 over 100, which is 9/100. Yeah? How many of you glance at number 2 and are immediately scared? Be honest. Yeah, it looks scary, doesn't it? Until you look at what? What do you see there? And what do you see there? Are they the same thing? Which means, what am I allowed to do with them as the math boss of this question? I can make it anything I want. If I made this x to the negative 4 to the 2 times x squared to the 3, is it difficult now? What do I do over that bracket? What do I do over that bracket? That would get negative 8. X to the negative 8, right? What would I do over that bracket? So it would be x to the 6th. Are these the same base? So what do I do with the exponents? To get what? X to the negative 2. Now, what does a negative exponent do to a base? Reciprocates it. Well, what's x? The base. What is it in this question? Negative 3/2. So what's the reciprocal? Negative 2/3. So this becomes negative 2/3 to what power? 2. What is that? 4/9. Easy peasy lemon squeezy. From scary to 2 seconds of work. Because who's in charge of the question? You are. You get to do what you want to them. This question is not going to come into your house and beat you up. Okay? What makes number 3 scary? It's a weird decimal, but what do you notice about that weird decimal? They're all the same. So what is it really? Well, let's not use x. We always use x. Sure. W3 times w to the 4th over w to the negative 2, which is w to the 7th over w to the negative 2, which is w to the what? 9th. 7 minus minus 2. W is 1.4 to the 9th. That's pretty darn hard to do without a calculator, isn't it? Because that's 14 over 10. 10 to the 9th is a giant number. 14 to the 9th is a giant number. What would you think I would want you to do there? Leave it. Because that number is impossible to find without a calculator. Do you think I want you sitting there going 1.4 times 1.4 times 1.4 9 times? Of course not. What is my goal with these questions? To check if you can multiply or to check if you know the exponent laws? Exponent laws, because who checked if you could multiply? Mrs. Bad Crumble in grade 3, right? Hadn't said it yet. What do you notice in 4? What's scary? The exponents are what? Fractions. What else? But what isn't scary? They're all the same base. So isn't that x to the 2/3 over x to the 5 plus 1/3? What is 5 plus 1? X to the 6/3. What should I do with every fraction I see if I can? Simplify. What does 6/3 simplify to? X to the 2/3 over x squared. Are they the same base? They are, aren't they? So what do I do with the exponents? Subtract. What's 2/3 minus 2? 2/3 minus 6/3 is what? Negative 4/3. So my answer is 7 to the negative 4/3, correct? Is that allowed?
No.
Why not?
Because it's going to be
What do negative exponents do to bases?
reciprocate.
So this guy is really right now what?
1 over 7
1/7 to
to the
the 4/3. And we would leave it that way. Could I write it with the radical sign if I wanted to? It'd be the cube root of 1/7 to the 4th power, right? But again, what is my goal? How many ways you can write something down, or showing me that you know the exponent laws? Showing me that you know the exponent laws. Does that show me you know all the exponent laws? Absolutely. What happens if I have more than one variable? You just put the right variables together. X's go with X's, Y's go with Y's. What's the answer? Is that okay? Why not? Not allowed to have a negative exponent. Where does it go? Don't say it goes to the bottom, because what it was already at the bottom. It reciprocates. So it becomes x to the 5th over y squared. When you say it goes to the bottom, as soon as I give you a question with a negative in the denominator, what about number 6? It looks freaky, but is it? Of course not. What goes with what? A's go with A's, B's go with B's, and numbers go with numbers. You learned how to do 10 divided by 5 a long time ago. What is it? 2. 5 and 3 is A squared. 3 and negative 2 is B to the 5th. Done like dinner. Easy peasy lemon squeezy. All in your head. Takes 2 seconds. What's weird about 7? Anything? It's decimals. So what can I do if I don't like the looks of something? Rewrite it so it's the way I like it. X to the negative 3 to the negative 5th. Hey, wait a minute. That looks just like the notes Mr. Myers gave me. Negative 5 times negative 3 is x to the 15th over x to the 5th. 15 minus 5 is x to the 10th. So it's 1.5 to the 10th. Would we leave it that way? Sure we would. Oh, barf. Scary. Scary, scary, scary. Why is it scary? Because there's more than one way to do it. And as soon as there's more than one way to do it, you guys get confused. What is one way I could do number 8? What is one thing I'm allowed to do? Jack?
You could apply the 1/3 to everything inside.
I could apply the 1/3 to everything inside. I can distribute, yes? So that would be 8 to the 1/3, A to the what? 1, because 1/3 times 3 is 1. And B to the what? 2. Okay. I don't need to write an exponent of 1, so that can disappear. Okay. What's there that's ugly?
The 8 to the 1/3.
But we know how to deal with that. Where does the denominator go? Outside. 8. What's the cube root of 8? 2. AB squared. Nothing to be scared about. Right? There's another way you could do that, which is the cubed root of 8a cubed b to the 6th. But I'm going to review that in this unit on radicals. This is the way you would do it exponentially. But if you remember this, could you do this? Would that be okay? Of course it would, because I don't care. Oh my good gravy. Is 9 really scary or pretend scary? Pretend scary. Because what is it really? 4 over 2. Oh, duh, what's that? 2. And then it's a to the negative 2 over a squared. What is that? Negative 2 plus 2 is, or negative 2 minus 2 is a to the negative 4. And then b to the 2/3, b to the 1/3. What's that? B to the 1/3. What there is ugly? The a to the negative 4. So it's 2b to the 1/3 over a to the 4th. Ease peas lemon squeezy. You all do 10. And then I'm shutting up and letting you practice. Now, listen up. There's the right answer. You can check it in a sec. 15, 16, 17, and 18. You need to do enough of that, and there's no answers. You need to do enough of that that you feel comfortable. Right? Now, I haven't given you answers on purpose because you know how to do this. All right? It is 1:54. At about 2:15, I'm going to start putting up answers to this. Let's say you do A, B, C, D, E, and F, and you get A, B, C all right. You know what you're doing? Most likely. Everybody understand? I will put answers up till the end of page 17. Page 18 is going to be your first assignment. It will be due for marking at the end of tomorrow's class. So tomorrow I'll teach and I'll give you some work time. We will also go over all of these to make sure you know what you're doing. Then you can look at 18 and see if you need to make any changes. Does everyone understand? When I say it's due for marking by the end of tomorrow's class, I mean it's due close enough to the end that we can actually mark it, right? It's not going to be due at the end of class, or how could we mark it? Everybody good? Everybody understands? It is 1:56. You have now 20 minutes. You can work with whomever you wish. You can move wherever you want. I do not care. I am going to be circulating the classroom as always, but first I'm going to pee. Everybody good? Yes, if you need to pee, you may do so too. Or get a drink, or whatever it is you need to do. Rhea, what do you need? Back to question 10, certainly. Everyone is good? I'm going to pause the recording. I'd just like to say the microphone was on for all that. No names mentioned. I told you I was recording the key. So yes, we have nasty kid was breathing in my ear. I bet you will have forgotten the formulas for spheres and cones.
Yeah.
So, just to remind you, actually, you know what? Don't even do 13 and 14. Screw them. We'll practice algebra later. That's more algebra practice than it is exponent practice.
But 10 grams of protein. That's crazy. That's not a good thing.
Now, I'm asking this from a cultural standpoint. Do you eat meat?
Yeah.
Like red meat? Like beef? You don't eat beef? Lamb? No. So you eat chicken? Okay. You're probably still getting enough protein in your diet. You don't need that.
Yeah, that's why you have to write it.
Well, I'm just saying, no. I'm just saying that the protein that's in there, your body doesn't need, which means when you eat it, you're adding, yes, 10 grams of protein, but you're also adding the 21 grams of sugar. Your body doesn't need protein. No one in North America needs protein unless you eat absolutely no meat. And when I say no meat, I am also including eggs, cheese, dairy. If you eat none of that stuff, if you are a full-on vegan, then you might need more protein. But that's only if you don't eat rice and beans mixed together. And if you're a vegan, what else is there to eat except rice and beans mixed together? And rice and beans mixed together makes it a full protein, and you will be fine. What? I know there's a lot of vegetarian protein. Well, soy has estrogen in it, which is fine for you. But if I plow into some soy, I'm going to get boobs. Now, I'm already doing a good job of growing my own, Hallie, without worrying about soy, because I'm fat. But, Hallie, if you mix rice and beans, of any kind of rice and any kind of bean, you get a complete protein. So you're fine. And the way we eat in North America, we eat so much food, you get enough protein. But we have this weird thing in North America, and people believe it. Oh, you got to get protein powder. Bill. You don't. You get enough protein for your body to succeed just fine eating 2 meals of meat. Less than 2 a week, and you'd have enough protein. Yes. Protein is a lie that has been perpetrated on us, so we spend more money on the powders. which, by the way, your body doesn't absorb properly because it's not real. You think our caveman ancestors went down to the GNC and picked up a bottle of whey protein? No. They killed a mastodon and ate it. And they did just fine. As a matter of fact, I would bet that the toughest human on the planet today couldn't have a chance against a caveman. At all. But that's just me. I could be wrong.
The microphone may be on. But the broadcast on. They ain't ready for it. They ain't ready for it.
You guys are funny.
Who's that? Yeah, I forgot about that. Hey guys, if you really want to know how to get the answers, photo math.
This is app called photo math.
Get you the answers.
Yes, I'm aware of that. Which you're welcome to use. I don't care. You are more than welcome to do that.
Can you do it on a test, though?
You're welcome to. I don't believe that photo math shows the work.
It does. It does.
Okay. So, when was the last time you were in my class that I allowed you to have your phone out for a test? Exactly. Oh, I see what you're saying. All right, I'm with you now.
That's cool. It actually gives in-depth
Yes?
For this question, would this negative 2 to the power of 2, would that be negative 4?
No, because the negative 2 is all of x, so it's negative 2 squared, not negative 2 squared. Do you hear the difference?
Like this
It's
bracket?
negative, yes, because x is negative 2. It's not negative x. All of x is negative 2. And x is being squared, which means negative 2 is being squared.
Yeah, so it's
So I should do this one. I should do this one first. No. A little better.
Sir,
What is that?
this is also a bracket anyways.
Yeah.
You do it your way, I'll do my way. Well, photo math.
You already asked me that, and I already said yes.
Tell me otherwise.
18 is what I am marking.
Negative 12.
Whoa, I was on route. I was on route. Okay, and then you replace the negative 2. Oh, it's negative 2. What? Wait. Hold on. Negative 2, and then that's negative. Yeah, 2 negative, positive.
That's right. He's doing the right thing.
Yeah.
But it's a gigantic number.
Scientific case. Yeah, no. I was curious. Oh my god. Wait.
Yeah.
I need help with this question.
Simplify it first. Why would you substitute in 7 things when you can get rid of numbers? What can you do with x and y and y there?
Cancel it out.
You can do all kinds of canceling and make it way simpler. Sub in until you've simplified. That's why we call it simplifying, Rhea. When you simplify something, stuff is made what? Simpler. Ladies and gentlemen, when should you simplify? Always.
I can't tell any difference, but I've just been happy. What? No. I don't know if it's good. I haven't felt like any difference, but I've just been happy.
Do you really feel a difference right now?
I don't know. It's probably better for me. It's probably going. It didn't say I read the whole package. It's like $3,000 worth, but there was
No, you did not.
no. It says consult. Doctor said that you're recommended. I like how people already the main ingredient is brown rice syrup. I've never heard of brown rice syrup.
It's the same thing. You can get sugar from every grain. So they take rice and they get sweetness. Yeah. Same way you can get sesame oil out of a sesame seed. Rice is sweet. There are types of rice that are very sweet. So you can make a syrup out of it.
So even like some boring rice, like basmati rice, like
Well, basmati doesn't have a lot of sweetness to it. But there is like jasmine rice. And, right? That's something that people that have my disorder have to be very careful with, because a lot of things are sweetened with sugar syrup made from barley. Barley is something I can't eat, but it's very, very cheap to sweeten things with barley syrup. So a lot of food companies use barley syrup because it's cheaper than sugar. So even Rice Krispies, which you would think would only be made of rice, have barley in them, so I can't eat them. Pardon me?
Could we cut it out the recording? What we said?
Is this still recording?
Of course it is. I told you I was recording all the answers. It probably isn't picking you up. And why do I need to cut it out? You say bad things about me? Well, then what difference does it make? And there's no names on there. Except mine.
Thanks, Arcurate. And Jashin.
All right, ladies and gentlemen, as promised, they have been recorded with work for everything except the very last 10. They just have the answers because we're running out of time. You can check your work, of course, right now, or you can check online later. This one messes kids up because of this. If I have negative x cubed to the fourth, that is negative x cubed 4 times, right? And once you do a negative times a negative, it's positive, negative, then one more makes it positive. So that's why it becomes x to the 12th. Then x to the 12th, then x to the 4th is x to the 16th. 16 times 3 is x to the 48th. Then you would bring that in there. But that's a big number. So if you left it like that, I'm perfectly happy. Some of your calculators will show it to you properly. Some of your calculators will show it to you in weird scientific notation, which is why you're allowed to leave it like that. Okay? What's the key here? Simplify first. Do not just start substituting. Because when you simplify, you will notice you got rid of a bunch of this crap and got down to that before you even did any math. Always simplify every chance you get. The beginning of a question, the middle of a question, the end of a question. Always be simplifying. Okay? I told you to skip 13 and 14. There is the blue ones are powers. Power, 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 and the green ones are the radicals. Radical, 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 and that one is already right. Remember, all of these are on YouTube. Don't bother trying to race through and copy them down now. Check it later. Again, radicals are green, powers are blue. Power, 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 power. Radicals, radical, 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 radical. And these last ones I didn't show. Did I show work on these? Yeah, I did show work on these. Answers 27, 9, 8, 4, 9, 216, 16, 1,400. This shows all the work. The answers are at the bottom. And this one, I didn't show any work. I just have the answers there. But by then, you should know what you're doing. The thing to remember, negative exponents means reciprocal answer. And then, of course, the last page is what matters for tomorrow, number 18. I will be going on tomorrow, but you will notice the more intelligent and I shouldn't say more intelligent, the more astute members of the class will notice that 1.4 is a multiple choice review of exponents. It's all multiple choice. We're going to do that tomorrow. You can work on it in a group, of course. It won't count for marks because it's multiple choice. And in multiple choice, you can always work backwards and find the answers without actually knowing how to do the math. Then you will write a quiz when it is time. Don't peek. Then there will be a sneaky exponents assignment where it actually is snaky and difficult and twists around you and tries to squeeze the life out of you. Then we'll have our test. That test will occur 100% sometime next week. Everybody good? And it will only be on exponents. Your first test. Yeah? Yeah. Now, for my front row gentlemen, I am turning off the recording.